No, we're recording. Okay, so this is Monday's class for my applied math students. And we're starting with page 391. We're going to try to refresh your memory on what quadratic functions are and what they look like. Okay, so let's start by just kind of some general knowledge here. Quadratic equations are any equations that have x squareds in them. When you graph them, they always look like parabolas. And there's three different forms we now know. This is what we call standard form or general form. And that one doesn't tell you much. You know what it tells you? That number there is right there. That's the y-intercept. Oh, and this number here, if it's positive, it's a parabola like the one I've drawn that goes up. And if a was negative, it'd be a parabola that goes down like that. And also, if a is 1, which it very often is, then I call that the parent form of the parabola. And then I know that from the vertex, which is the lowest point or the highest point, you would go 1 to that direction and 1 in this direction. You'd go 2 in this direction and 4 in that direction. You'd go 3 in this direction and 9 in that direction, because aren't these numbers 1 squared is 1, 2 squared is 4, 3 squared is 9. So we call that kind of a normal parabola, or the parent function of a parabola. But if a is a number like 2 or 3, then this parabola gets skinnier and skinnier, or maybe a better word is narrower. We don't want to fat shame our parabolas. So the parabolas get narrower as a gets to be a bigger number, or a more negative number, right? If a was negative 2, it'd be an upside down parabola, just twice as skinny as, or twice as narrow as usual. But if a was a fraction, like a half, or a third, or a quarter, then the parabola gets wider than usual. And that's all that this form tells us. It tells us kind of what direction it is, whether it's narrow or normal or skinny or wide. And the C tells us where we hit the y-axis. Great. Here's a more useful form. And notice it still has an A in it, but it doesn't have a B or a C. It has an H or a K. Who remembers what that one is? What do we call that form? So if this one is standard, or again, I think your textbook calls it general. Same thing. Anybody remember what that one's called? What do we call that form? I'm looking at the chat, seeing if somebody has an answer.
Vertex?
That's it. This one's called the vertex form. And this one's coming back in our next lesson too, right? Tomorrow's lesson is going to go back to vertex form. But the homework that you had over the break focused on mostly this form. Notice it's still got A. A is the same in all of them. What are these two numbers here? Those are my x-intercepts. We call this factored form. So on the graph of a parabola, let me make a nicer graph. If I make a nice graph of a parabola like this guy here, oh, that's a lovely parabola. So this here, and this here, and this here, and this here are my 4 most important points of the parabola, right? Those two things are called the x-intercepts. So this is x-intercept, x-intercept. Get it? It's where it intercepts the x-axis. This is my y-intercept. It's where it intercepts the y-axis. And this guy here is my maximum, or my minimum. In this case, it's my minimum. And it's also called the vertex. So these points here have, of course, x and y coordinates to them. And on these 3 formulas, this point here, the vertex, is the h comma k. So the vertex form tells us the vertex. Standard form, again, only tells us this number here. So this would have coordinates 0 comma c. Get it? Because c is the y distance. And of course, when you're on the y-axis, your x value is always 0. And these two things here are the x-intercepts, which means that their y values are 0. But their x values are right here, x1 and x2. So that is everything we kind of know about parabolas so far. Notice all three forms have A, which is kind of cool. Right? They all tell us whether it's right side up or upside down. They all tell us whether it's narrow or wide. But the four kind of important points that you need to kind of graph a parabola, they're not all in one version of the formula. So we're in factored form. For each function, notice the first thing they ask you is what's the x-intercept. So if I was doing 4a, the x-intercepts here are these two numbers, but be careful. Remember that x-intercepts happen when y is 0. And hopefully you remember from grade 10 that f of x is just a function way of saying y. There's no difference between these two equations logically. So if y is 0, what are my x-intercepts? So you have to ask yourself, you say, self, what number would x have to be to make each of these two things 0? Right? Because think about, look at this equation. Look what it's saying to you. It's saying some number times another number, right? Number times number is 0. If you're timesing together two numbers, fill in those blanks. Doesn't at least one of those blanks have to be a 0? Possibly both? So if that makes sense to you, what you should be thinking, what you should be thinking is, what is this x so that I get a 0? And in this case, this x would be 1. So notice this number here is right there. What would this number have to be so that this entire factor is 0? In other words, what plus 1 makes 0? Oh, well, that x would be -1. So notice that the version of the formula, right, y equals a times x minus x1, x minus x2. Notice that if this is a plus 1, the formula says that it's minus. What would you have to minus to get to plus 1? Well, you'd have to minus -1. So when you're reading the x-intercepts from all of these questions in number 4, you're always taking the opposite of those two numbers. So there's my A answer for the x-intercepts. The x-intercepts are 1 and -1. So there we go. I can start graphing this thing. 1 and -1. There's the x-intercepts of the parabola. Now, what else does it want? Oh yeah, it wants the y-intercept. Ugh. How do you find the y-intercept? Well, the y-intercept happens when x is 0. So if this is the equation, the y-intercept, I hit this y-axis when x is 0. Just plug in x is 0. And you'd get, well, let's see, what's 0 minus 1? -1. What's 0 plus 1? Plus 1. Multiply those two things together and you get -1. And there it is. So there's my, let's make a little chart or something here. So my x-intercepts are 1 and -1. And don't put a bracket around that, right? Because in fact, maybe to make sure that you don't think that that's one pair of coordinates, because it's not, you could say 1 and -1. Or you could get really fancy and say, hey, the x-intercepts are coordinates 1, 0, which is that point, and -1, 0, which is that point. But I'm happy if you just write it like this and don't put a bracket around it. Y-intercept, we just figured out, is -1. So there it is. Now, how do you find the vertex? What do you know about the vertex? Well, what do you know about parabolas in general? Parabolas have what we call an axis of symmetry. In fact, there's a reason why that's the next thing that they ask for. What's the axis of symmetry again? Oh yeah, the axis of symmetry is a line, an imaginary line, that cuts your parabola in half. So it's a mirror image, and I didn't draw this one very good. But it's a mirror image so that the parabola on the left side is identical to the parabola's shape on the right side. So What is the equation of that line? Well, if you remember back to linear stuff, vertical lines are always just x equals something. And in this case, it has to be h. So the equation of this line, whatever that line is that it's x equals that h number right there. So in this case, this one's pretty easy. So my x-intercept, my y-intercept, my axis of symmetry would be x equals something. What do you think that something is? Well, how about this? Like I said, the axis of symmetry means that the left and right sides are the same. So the distance from here to here has to be the same as the distance from there to there. And again, sorry I drew that so badly. But it makes sense that the x-intercepts have to be the same distance away from the axis of symmetry. Otherwise, it wouldn't be symmetrical at all. So what's halfway between 1 and -1? And the answer is 0. In other words, in this parabola, the y-axis is the axis of symmetry. And I can just draw it if you like. So there it is. My axis of symmetry is x equals 0. And I know that the vertex is h comma k. And I just figured out that h is 0. And in this case, we already know that this point is -1. So my vertex for this one's pretty easy. It's just 0, -1. And there we go. There's the 4 things it asked for. X-intercepts, come on, move over you. Y-intercepts, the equation of the axis of symmetry. Notice it's an equation. It wants x equals. And the coordinates of the vertex. So that's all of the work I just did right here. Ready to go. Now, the other thing I would maybe add to this is I would want to sketch, but it doesn't want to sketch for number 4. I did one anyway, because I like to visualize this stuff. To me, all equations are graphs, right? Like the more you can visualize it, the better you're going to understand it. Okay, so that was 4A. Let's do another one together. Let's do 4B. Okay, so I'm gonna, how do I do this? Pick that up and move it over. There we go. Move it over to where I have some room to work. If you're wondering why I'm not working down, it's because I already have some other questions down there I want to do later. Go away. Okay, so let's do B now. For B, I have f of x equals x plus 2 times x plus 2. What do you notice about this one that's different than the last one?
There's no subtraction.
There's no subtraction this time. So, and do you notice that both of the x-intercepts here are the same? So in other words, it only has one x-intercept. So try to imagine that. Again, a sketch is such a helpful thing. If it only has one x-intercept, so in this case, the x-intercept is the opposite of plus 2. It's -2. Are we allowed, okay, the question I just got in the chat is, are we allowed to use Desmos for everything? And I'm going to say most things, but not everything. Remember the last test where I gave you kind of a section with a few of the easier questions just to make sure that you understood it without punching everything into a grapher? It'll be like that for this test too. So there'll be, actually, number 4 is actually a good example of something I would not let you use Desmos for. I want to see if we give you a basic factored form equation, if you could figure out, you know, these things. So follow along closely. You would not be able to use Desmos on a question like this. Okay? So good question. Okay, anyway, so if this is the only x-intercept, right? Like that's it. This would be -2, this would be -2. So if that's the only x-intercept, what does that mean? Well, it means it can't cross the x-axis anywhere else. So that means that this must be where the vertex is too. So what's the coordinates of that? That's 2 to the left and none up. Now, if that's the vertex 2, how do I know if the graph is going this way or if it's going this way? Red or blue? Which one is it? What do you think? Who can tell me which way it's going to be going? How did you know that? You're right, it's the blue one. How did you know that? And there's actually two ways. Right. First way I could figure it out is to figure out the y-intercept, right? If the y-intercept is positive, it's going up. If the y-intercept's negative, it's going down. So let's go to the equation. The y-intercept happens when x is 0. And 2 times 2 is 4. So 1, 2, 3, 4, and I drew that really badly. It's got to be going that way, like that. So yep, it's that one. There's another way I could have been able to tell as well, that it has to be going up. Of course, I needed the y-intercept anyway, because it's one of the things they asked me for, so there it is. But what's the other way that I knew right away this was going up? Remember that all 3 versions of the equation, including factored form, do have an a number in front. Now, in this case, for a, b, and c, all of these a numbers are 1s, but 1 is positive, and if a is positive, it's going up. In fact, none of the ones in number 4 are going down. Oh, wait, sorry, I'm lying. D is going down. Haha. So I knew it was going up just by looking at the equation and saying, oh yeah, a is positive, it's going up. Okay, so we found 3 of the things we were supposed to find: x-intercept, vertex, and y-intercept. We still need the axis of symmetry. What is the equation of the imaginary line sawing through that parabola? It's x equals same thing as that. It's always the same as the vertex's x coordinate. So my axis of symmetry. And if anybody wants to start a metal band and name them axis of symmetry, I don't think that name is taken yet. That would be a pretty cool name. Axis of symmetry is x equals -2. All right, what do you think of B? All right, C is actually almost exactly the same, right? 2 things are the same. D has some fun to it, so let's try D. Any questions? Feel free, again, stop me if you have any questions. Somebody said, I haven't looked at this stuff in 2 weeks, I don't know what's going on. Okay, well.
My brain is just, I don't know.
It's all good, man, don't worry about it. We'll spend the next couple days going slow. All right, so what are we looking at for D? Let's look at D. Y equals, again, f of x, let's call it y. -2 times x minus 2 times x plus 1. Okay, so first things first, what are my x-intercepts? Because I'm in factored x-intercept form. What's the opposite of that number? Actually, I don't need to say x equals. That makes it look like an equation. My x-intercepts are 2, which is the opposite of this -2. And remember, the formula is x minus x1, which is why this is +2, and x minus x2. So again, what does this number have to be if it was x minus something, and when I put in that something, I got +1? It must have been -1. Do you get the logic on why that is? If that logic doesn't make sense to you, go back to the original reason why that works. X-intercepts happen when y is 0. If there was a 0 over here, what would make this a 0? 2 would. What would make this a 0? -1 would. All of this stuff is based on logic and reasoning. So there we go. Logically and reasonably, that's the x-intercept. What's the y-intercept? This one takes a little bit of calculating. The x-intercepts happen when y is 0. The y-intercept happens when x is 0. So y equals -2 times 0 minus 2, 0 plus 1. So that's, I'm going to do this in 2 steps because my brain's not working that great either this morning. 0 minus 2 is -2, and 0 plus 1 is 1. What's -2 times -2 times 1? 4. Isn't that what we had for a y-intercept on the last question too? It's a popular number today. So my x-intercepts are 2 and -1. My y-intercept is 4. I'm ready to start sketching this thing already. And I know it doesn't say you have to, but it's so much easier to visualize it when you've got a visual in front of you. Okay, so x-intercept is 2, so 1, 2. Y-intercept, other x-intercept is -1. My y-intercept is 4. 1, 2, 3, 4. Now, if I didn't notice that my a value was a negative, I better notice it now. It's definitely an upside-down parabola. And you can kind of see that it's going to go past this point and do that. What's the coordinates there? How do I find the coordinates at that point? Well, I know that this vertex has an x number that's halfway between this x number and that x number. And this, what was this x number again? This was 2. And this was, oh, wait a minute, sorry, other way around. This was -1, and this was 2. What's halfway between -1 and 2? How do you find halfway between any two numbers? Any ideas? If I gave you just any two numbers randomly and said, hey, what's halfway between these two numbers? What do you do? What if you had a course based on 2 tests that were worth the same and you wanted the grade? You divide them by what? There it is. You add them and you divide by 2. That works. So to find the x-coordinate of my vertex and the axis of symmetry number, add up these two numbers, these two x-intercepts, and divide by 2. So -1 plus 2, so this is a half. And I don't really want a decimal. So that's a half. So that means that this is x equals 1/2. So there it is. My axis of symmetry is x equals 1/2. And now my vertex is 1/2 comma something. What's the something? Well, I can figure it out by using the equation. Y equals -2 times x minus 2 times x plus 1. What's the y coordinate when the x is 1/2? And as I write this down, I feel the psychic pain vibes coming through the internet, because I know some of you, fractions are not your friend. And somebody just put in the chat, can you turn it into a decimal? And the answer is sure. If decimals are more comfortable for you, go ahead. I'm never going to take your regular calculator away from you in this course, so I might not let you use Desmos on a question like this, but you can certainly have your scientific calculator if you'd like. If fractions are not your friend, we're not going to force you to hang out together too much. There's a few things in this course I'd rather see as fractions than decimals, but this isn't one of them. So 0.5 minus 2, I don't need a calculator for this. 0.5 minus 2 is -1.5. And 0.5 plus 1 is positive 1.5. And 1.5 times 1.5 is actually, if you know your times tables, your perfect squares, 15 times 15 is 225. So this is actually y equals -2 times -2.25. And a negative times a negative is a positive. So if you double 2.25, you get 4.5. And or you could say 4.5. Or, whoops. 0.5, comma 4.5. So there it is. X-intercept, y-intercept, axis of symmetry, vertex. The Fab Four. The 4 things you should always be able to find on any parabola. All right, that was a tough one. That was as tough as these things get. But I still want to do one more, right? E and F are, again, very similar, so I'll just do one of them. I'll do F this time, and then you can, if you haven't tried their homework yourself, you can go back and try E yourself. Okay, so there's D. Let's do either E or F, and again, I'll pick F. Let me just erase all this. Yeah, that didn't quite work. The erase function on here is kind of hit or miss. Okay, there. All right, so now I'm looking at f. F of x equals 4 times x minus 1 squared. Now, this should look kind of familiar. F is actually just like b. There's only one difference. There's a 4 in front here instead of a 1. So what does that mean for this question? Well, it still means that for f, let me copy the question first, and again, I don't need to say f of x, I'll just say y. It means that there's only one x-intercept, and that's x-intercept is the opposite of minus 1. Again, what would go into this blank to make x minus 1? And the answer is just positive 1. So the x-intercept is positive 1, and there's only one of them. And if there's only one x-intercept, it can't cross the x-line twice, so my vertex and my x-intercept are the same thing. So I have a graph where 1 is my intercept. Now what's the y-intercept? The y-intercept takes a little bit of calculating. It's when x is 0. And careful here. What's 0 minus 1? Well, it's negative 1, but I'm squaring it. What happens when you times a negative by itself? Oh yeah, you get a positive. So this is 4 times 1. Once again, we have a y-intercept of 4. Very popular number today. 1, 2, 3, 4. And there it is. That's all I basically, oh wait, one more thing, sorry. We know the vertex, x-intercept, we need the y-intercept, we need the, we need the axis of symmetry. So we got the y-intercept, the x-intercept, the vertex. What's the AOS? Oops, that was supposed to be a colon. There we go. What's the axis of symmetry? Well, the axis of symmetry is always x equals this number. So x equals 1 would be the imaginary line that cuts this parabola in half. And notice, if you drew this one with kind of a similar scale to the last couple I did, this 4 makes it much skinnier. And, you know, just to show you, let's go and play with a little bit of Desmos here. I find Desmos is always kind of one of the easiest ways to, oh, what is this? Oh, that's what I was doing with my last class. No, let's just give me a new one. Close that one. Graphing calculator. Desmos is such a nice, easy way to kind of check out what's going on. Okay, so here we go. So let's go to y equals, and then sum a times x minus x1, and yes, I'm going to want a slider for that, and x minus x2. And yes, I want sliders for everybody. So there we go. What was the question we just did, though? The question we just did had x1 and x2 were both, that's how good my memory is, were both 1. Okay, so both of these were 1s. So there we go, 1 and 1. Yep, there we go. And what was a? A was 4. And notice as I change a from 1 to 4, notice it's getting narrower. Oops, too far. 4. And look at that. There's the y-intercept. And there's the x-intercept. And it happens to be the vertex. Let's take a look at one of the other ones we did. What else did we do? We did, we did D, where a was -2, and then I had 2 and -1. So I had a was -2, and notice as soon as I cross into the negatives, we're upside down now. -2, and that's how good my memory is. What were they again? They were 2 and -1, right? 2 and -1, 2 and -1, 2 and -1. So x is 2 and -1. And is that the sketch that I had before? I think it is. And we can check. What did we get for a vertex again? Oh yeah, 1/2 and 4.5. Whoever asked about decimals, Desmos is like you. Desmos likes decimals. And what did we get for a y-intercept again? Oh yeah, it was 4. 4 was a popular number. And there it is. So there's how we can use Desmos to help us. But to be honest, this is kind of a question that should be Desmosless. You should be able to do this guy without Desmos. So there we go. So that was number 4 from the page, whatever it was, homework. What page was it again? Move over now. Move over somewhere. Page 391. Is there anything else from 391 I want to do? Yeah, let's do a word problem. All right, let's play with a word problem or two. I've got a couple here. I'm going to go through a couple word problems. Okay, Byron is planning to build 3 attached rectangular closures for some animals on his farm. He bought 100 meters of fencing. He wants to maximize the total area of the enclosures. He determines the function a of x that models the total area in square meters. Determine the maximum total area. Okay, so that's an interesting kind of question. So the maximum total area is going to happen when we have the y coordinate of the vertex. So we actually need to know the vertex, and that's the equation that we have. Well, interesting. They gave us this. This is what I would call standard form, right? ax squared plus bx. You're probably saying, well, where's the plus c? Well, if there's no c number, you just assume c is 0, which means that the y-intercept is 0. Okay, so it wants to know the maximum total area. Where does this thing hit its vertex? Well, if I have a vertex, I look like this. If I'm in vertex form, I should say, I look like this. Is there a way to make this equation look like that equation? And the answer is, well, yeah, but it's going to take a little bit of work. First of all, I need this a number to come out. So I'm going to do this. So a of x is equal to negative 2x squared plus 50x. So I'm going to factor out an a. Do you remember what factoring means? Factoring, you learned in grade 10, means take the biggest number you can out of those two things. Now you're probably thinking, well, I could take an x out of both those things. Yeah, but you want the x to stay squared. So all I'm going to take out is negative 2. And there we go, negative 2. Now, what would I do to change this thing so it looks like that thing? Okay, now, for this question, would 100% allow you to use Desmos. Let me show you what you'd have to do to this question if this was a course like a pre-calculus where you weren't allowed Desmos. So if there's people here double dipping and you're doing pre-cal 2, this should be familiar. Or if there's people thinking, hey, I'm in grade 11, maybe next year I'll take grade 12. Or maybe when I'm in grade 12, I'll go back and do my 11 pre-cal. It's not that much harder. It's just more algebra. Here's what we're gonna do here. We're gonna do something called complete the square. And I'll show you this, and then we'll go back and do it the Desmos way in a sec. Okay, if I have something like this. What goes in that blank so that this would be x plus 3 squared? I'll let you think about that for a sec. Now remember, what I mean is, what would I have to put in this blank so that this thing factors so that it's x plus 3 times x plus 3? I'll give you a sec to think about that. What is the number that goes in that blank? Somebody can turn on their mic or say it in the chat. What would go here so that it would equal that thing? And the answer is 9. Correct. It would be 9. 9 would go here. Okay, let's try another one. What if I had x squared plus 10x plus blank? And this time, I'm not going to tell you what this factors to. It's going to factor to x plus something squared. It's not the same as that. It's not the same as that something. But that's going to simplify to x plus that something, x plus that something. So what if I wanted to fill in all those blanks? What's the relationship between 6 and 9 and 3? Well, if I square 3, I get 9. If I double 3, I get 6. So what numbers go here and here so that if I get this number and I square it, I'm there. If I take this number and I double it, I get 10. There you go. So these are 5s, and this is a 25. So what we're doing is called completing the square. See, these things factor into what are called perfect squares. This thing here you learned in grade 10 is called a perfect square trinomial. And when you factor it, you get the same number times itself, which is what squaring is. So if I had, I'll do one more. If I had x squared plus 14x plus something, what's the something that allows me to get a perfect square? And how did I get from here to here? I took half of this number and I squared it. How did I go from here to here? I took half of this number and I squared it. Quick, what's half of 14 and then squared? Well, half of 14 is 7, and 7 squared is 49.
7.
So this is a 49. So that's what I'm going to do back over here. I would like to put a number in a blank here so that I get half of 25 squared. So I'm going to use my calculator. Half of 25 is 12.5. And 12.5 squared is, gee, I don't even know if I know what 12.5 squared is. Oh, I'll use a calculator and figure it out. 12.5 squared is 156.25. So I'm going to go plus 156.25. Now, problem. We do have a problem. This thing here, we have a problem. There's drilling going on. This thing here is an equation. You can't just add numbers to it. You change what it is. Unless you did something really clever, like you took an equation and you added a number, but then you subtracted the same number right away. So that's what I'm actually going to do. I'm going to take this number here that I added, and then I'm going to minus it right away. So you're probably looking at that going, well, what's the point then? Well, because this is 0. I didn't change the equation. But then I'm going to take this number, which is kind of not the number I want. This is the number I want. This is the number I don't want. I'm going to take this number that I don't want, and I'm going to kick it out of the bracket. I'm going to say, thanks for coming along, number. You allowed me to add 0, so I didn't change the equation, but I don't want you in my bracket. Get out. Now, if I factor this number, or defactor, expand, distribute out this number from the bracket, notice it has to get multiplied by this -2, or else it's not the right number. So -2 times 156.25, a negative times a negative. Calculator, come back. What's that number times 2? 312.5. So plus 312.5. Now, we have ourselves what's called a perfect square trinomial. How did I go from here to here? How did I go from here to here? I just square rooted that number. So there it is. A of x is equal to -2 times x minus whatever the square root of 156, and remember, I already kind of know it was 12.5. And after all that complicated looking algebra, that's a decimal. Notice, hey, that's the vertex form. So the vertex is 12.5, comma, 312.5, and that's my answer. The maximum total area is this number here, 312.5. So if you were going to do the grade 11 version of this course, but the pre-cal version of it, this would be the way you'd have to do it. For you guys in this course, we don't expect that you can do this level of algebra, but this is how it works. This is how the equation behaves. You are allowed to use the technology to find this number. You are allowed to go to Desmos, and let's just erase all of this stuff, and plug in the equation from the work, which is y equals, you can actually type in a of x if you want. Desmos doesn't have a problem with that. Y equals -2x squared. So you can type in y equals -2x squared. What was the rest of it again? Plus 50x. So plus 50x. And now, okay, now here's the problem. We're looking at it and go, well, it's linear, it's a straight line up and down. Well, no, it's not. It's a parabola. It's just we're looking at it kind of funny. So what we can do is we can kind of play with stretching this down, stretching this down. I have a touch screen. Well, you're using a phone too when you're using Desmos on a test. You have a touch screen. And then it's like, oh, there it is. So, okay, that's high enough, but I kind of want to look at it a little better. I'm gonna change my x-axis. I don't need to go all the way down to negative 300. I think this thing is fine at like negative, I don't know, negative 5. Good enough. And I don't have to go all the way to 200. Let's see, that's one, so 50 looks like it'd be plenty of room. There it is. Beautiful looking parabola. And there it is. What's my maximum? Hey, there it is, 312.5. Now, if anybody wants to do this with the TI is not really any different. It's just a few more things, a few more commands you got to do. You got to go to, first of all, make sure all your stat plots are off. They are. Then go to your Y list. Get rid of whatever's there before. Type in negative 2x squared plus 50x, and then hit enter, or not hit enter, sorry, hit graph, and it's going to do the same thing that I did in the first, like, yeah, well, I graphed it for you, buddy, but you can't really see it because of the scale. So this is one of the things about the calculator that's nice. You can actually ask it to find you a scale without having to kind of just enter numbers. You can say zoom, and then I think it's, is it zoom 0? Yeah, zoom, no. Yeah, zoom 0, zoom fit. Click on zoom fit, and it will change it so that you can see the entire graph. Now it's kind of, well, it tried. Okay, at least it shows me, and it's like, well, you want to see all of this part of the graph? No, no TI. I don't really care about the negative part of the graph. So at least now it gives me a place to start. I can change the window and go, okay, I don't want anything negative, so I can start at like, I don't know, -1 is good enough. And it wasn't far enough over, so again, change that to, I don't know, 20 or 30 or something. And again, I don't care about any of the negatives, so make that just, I don't know, -10. The reason I leave any negatives at all is I don't like it when the axis isn't visible. So there, now graph it. There we go. Oh, it's like, oh, wait, no, not enough. Okay, go back, window, change it some more. So I'd like to maybe go to 40. Is 40 enough now? And I need to go a little higher. So is 400 enough? Oh yeah, right. I already knew the maximum was 312. So there we go, graph. Now that I have the entire graph on my screen, how do I find this point here? Well, your TI doesn't know the word vertex, so it knows the word maximum. So click on 4, and then left boundary. So go move your cursor until you are on the left side of the maximum you want. There, enter, and then move it to the right side, and then it's going to take a guess, and you're going to say that's not a good guess. Calculate it, please. And there it is, 12.5. And the Y value is the maximum area. And that's it. So that was the word problem. So I'm going to leave you with number 9 to try for yourself. So if you did number 8, or you tried number 8 and you didn't get anywhere, you're going to try number 9. Now, number 9 doesn't actually give you the equation, but if you look back in your notes, I think we did one kind of like this. So I'll let you try it, and if there's people who still have to worry, still haven't tried the questions from number 4, which, oh, I guess I moved the number 4 questions. So we did A and B and F. There's a couple more in number 4 you can try. Okay, and then see if you can do number 11 as well. We'll go over those ones tomorrow too. Okay, so I'll call it a day there. If there's still questions in the homework, some people have already kind of admitted that they forgot they had homework over the break. If there's still questions from the homework that you haven't tried, all I just went over today was I went over 391, number 4 and 8. You can try 9, and we'll go over 11 tomorrow, and then we'll go over maybe some questions from 405 tomorrow as well. And again, we won't really hit a new lesson until later in the week. Okay, so for today's homework, just kind of go back and make sure that you've tried as many as you can from here and here, and then and that should be it. We'll meet up again tomorrow. Now I already ran attendance. Before we run off here, let's make sure that we actually ran attendance. Okay, so actually I can close my video now.